We have a triangle here. I'm asking you to solve for m, k, and n. Class, we know that the interior angles of a triangle adds up to what number? So this is 45, this is 90, therefore this one has to be 45 degrees. Okay, that also tells me that this is in a right isosceles triangle. What does that mean? What do you know about the relationship between m and k? Same or different? Oh, they are congruent. So you can draw these hash marks on there. So whatever m is, k is. So if I use the Pythagorean theorem, I can just label it. Well, across the hypotenuse is the c value. So I'm going to write 8 squared. And because m and k are congruent, you can write the same variable for them. What does that mean? You can write m up here. So when I write my formula, if this is a c, a and b does not matter, then I can just say m squared plus, really, oh, I should have wrote the squared on the outside. And then from here I can just solve it. Class, 8 squared? 64. M squared plus m squared? M to the fourth? Remember, it's m to the fourth if it would be multiplication, right? So this is addition, so you're combining like terms. So this would just be m squared plus m squared, which is 2m squared. Should I take the square root and divide by 2? Class, what should I do first? You're going to divide. So now I have 32 equals m squared. Partner A, tell partner B the factors, numbers that multiply, to be 32. And we're looking really for a perfect square. Tell your partner. Class, could you use 4 times 8? You can, but there's a better one. What is it? 16 and 2. Square root of 16 times square root of 2 equals the square root of 32. Square root of 16 is 4. My answer is 4 radical 2. Now, if you remember back from first semester, this actually should be plus or minus. But can you have a length on a triangle to be a negative? No. So please do note that this is really plus or minus 4 radical 2. So 4 radical 2 and 4 radical 2. Okay, that's solving using the Pythagorean theorem. Let's use the shortcut. So I'm showing you both ways, and you can kind of pick a method that works for you. Okay? I have the triangle 45, 45, 90. Across the 45, this is really an x. So I'm just trying to show you guys how this works. Even though there's different variables, across the 45 is also this x. Okay, what does that mean? We don't have anything there, right? They're unknowns. But across the 90, you have x radical 2. X radical 2. So in this method, what you're going to do is, well, this is set equal to nothing, so I can't use that. Not set equal to anything, can't use that. But this one I can use. X radical 2 is equal to 8 centimeters. Just write that. X radical 2 is equal to 8 centimeters. And all I have to do there is just solve for x. Class, how do I get x by itself? Do you want to square it? If we squared it, that would be x squared times 2 equals 64. You could do that. I'm going to show you guys this other method, which we're going to need for the class. If this is what math operation here, what math operation is between x and radical 2? Multiplication. What's the opposite of multiplication? Division. So we're going to divide by radical 2. This side equals 1, so I'm left with 8 over radical 2. Class, does that look like the answer on the left side over here? No. What do you think we're going to do? We need to rationalize the denominator. What does that mean? You're going to take whatever's in the denominator and use that top and bottom. See it? Let's see what happens when we do that. 8 times radical 2, 8 radical 2. Radical 2 times radical 2, that's going to be a radical 4, and class radical 4 is 2. And then 8 divided by 2 is 4. The radical stays in the denominator. My answer is x equals 4 radical 2. What does that mean for us using the shortcut? We knew that this side was equal to 8. Then these are each equal to 4 radical 2. So 2 ways of solving special right triangles. You can use the Pythagorean theorem or the shortcut method.